So before we start doing examples, just a quick overview of what's happening. Again, what's impacting the amplitude, right? So when we put this together, it's the A value that's impacting amplitude, right? Our amplitude is basically the absolute value of A, right? And it's basically a measure of our wave above / below equilibrium, right? So what line is our wave bouncing back and forth from? So what's the height of the wave above it? What's the height of the wave below it? That's basically our amplitude, and that is impacted by the A. Equilibrium, well, we're now shifting the graph up and down, right? Our equilibrium usually starts along the x-axis, but it shifts up, right, to y equals c or y equals minus c, and our curve basically bounces back and forth, right, along that equilibrium. So that has everything to do with c. So the c value basically does that, and our equilibrium, right, will be the line y equals c, whatever that is. Or again, our wave will bounce back and forth between that action. The new period, well, as we saw, right, what impacts the period, we already canceled c, right, what impacts the period is b. And the new period, right, is always going to be 2 pi divided by that b. All right, and that gives us the new, again, all the normal action occurs on one full rotation if we think of a circle, but by having a value for b that's not equal to 1, right, this takes that and stretches that out or basically compresses it in. All right, and so we got that. And then the phase shift, well, that has everything to do with d, right? And so what that basically do is shifts the wave left or right, d units. And again, that kind of depends on if we are subtracting or adding d. So right now I'm subtracting it, so I'd expect the easy one to shift right. But if we were adding, it'd be shifting left. Okay, and we've got that. So these two right here impact y values. And just like the order of operations would say, multiplication would have to be done before addition. So we're going to hit all the y values with a first. We're going to multiply them. And then after, right, we're going to add or subtract the c, whatever comes there. And again, to all the y values. These two guys impact our x's, as we saw. And order of operations, again, we do multiplication before any addition and subtraction, even though it's in parentheses, right? Remember, everything is kind of reverse. I showed you why we do the division first and then the addition second. So we divide by b first, and then add or subtract d second to all the x values. And what we're doing again, over and over and over again, you've seen me, and hopefully we've just built it, right? For a cosine graph, what are the core data points? Well, all the quadrantal angles are where all the extrema and x-intercepts occur, right? And y bounces from 1 to -1 back to 1. So there's your core data. So we're basically going to be multiplying or adding c to all the y values, or dividing by b and adding or subtracting d to all the x values. Put that all together, we'll have a new table of data that we graph, and we can at least, if we can, if this is one cycle of cosine, then we'll have one cycle of this manipulated cosine just by doing all that. Same thing here for a sine wave, right? The classic data points, again, we have our quadrantal angles. This time it's at 0, 1, 0, -1, and 0. And so we just manipulate this data by adding, or excuse me, multiplying by a and then adding and subtracting c to the y values, dividing by b and adding and subtracting d to the x values. That'll give us a new set of coordinate pairs that will give us the graph of that transformed sine graph. And then we can do our analysis. We should be able to see the amplitude, we should be able to see the equilibrium, we can observe the new period, right? And we can kind of see that shift over to the right or to the left, because things usually happen along the y-axis, but things have been shifted now according to what D tells us to do. All right, so we should be able to observe all that and start answering a bunch of questions, range, domain, all that good stuff. All right, so let's get to work. There's an overview. Now let's do it.